Hey, this is Mr. Aiden. This is Pre-Calculus Honors. This is section 2.5, the Fundamental Theorem of Algebra. It's not only fun, it's mental as well. It's fundamental. So the Fundamental Theorem of Algebra, developed by a guy named Michael Scott. Oh wait, sorry. He developed the Fundamentals of Business. The Fundamental Theorem of Algebra, developed by a guy named Carl Friedrich Gauss. And what we know from previous studies is when we have something, a function, f of x equals a to the n, x to the n power, if we look at this degree right here, this n number, we said this n number, you can have a maximum at most this many real zeros, okay? So if it is in f of x equals x squared plus dot dot dot, you know you can have at least, at the most, 2 real zeros. Now, we know about complex numbers as well, which means our theory here, our theorem is going to be expanded a little bit, is we can say this n number is how many zeros we would have. And those might be real, those might be complex, okay? And so remember, this fundamental theorem of algebra just tells you that these zeros exist. It doesn't tell you how to find these zeros. It just tells you that these zeros may exist. So if we take a look here, we're going to find the real zeros of our polynomial function. And so we're going to do a little bit of factoring here. So we have x times x, that gives us x squared. What are the factors of positive 9? Are 3 and 3. So we have negative 3 and negative 3, which add up to negative 6x. And you can see how, which means my zeros, what are my zeros of my function, is x is equal to 3 and x is equal to 3, which means x is equal to 3 has a multiplicity of 2, which means it's going to hit 3, and it's going to hit 3, and it's going to hit right here at this spot. And you can see there's a 1 in front of this x, which means we go over 1, up 1, over 1, up 1, over 2, up 4, 1, 2, 3, 4, because it's a quadratic. And we can kind of sketch my polynomial out here, my quadratic out here, and it just lands on this x-axis because of the multiplicity of 2 at this x is equal to 3. Now, remember, we might have some real zeros, we might have some complex zeros. So we know, we can see x to the third power, we know there's at least 3 zeros, okay? And they could be a combination of real, a combination of complex. So let's see. We're going to factor out an x here. So we got x squared plus 4. And so you can see how x is equal to 0 is a function. Now, if we take this and we set this equal to 0, 0 equals x squared plus 4, we're going to subtract 4. Negative 4 equals x squared. We're going to do the square root, plus or minus the square root of negative 4 equals x, which means x can equal plus or minus 2i. Because remember, the square root of negative 1 is I, the square root of 4 is 2, so plus or minus 2i. And so here in this function, we know that the only real zero we have is 0 right here. Okay, that's the only place where this is a real zero. The rest are complex. You can see there's 3 real zeros here, though. There's 1 right here, x is equal to 0. There's a plus and a minus, so there's 3 total zeros. Only 1 real, and 2 of them are complex. Now, what does the rest of our graph look like? We're just going to plug in some values. We got 1 to the third power plus 4 times 1. That's going to give us 5. We're going to plug in negative 1. We get negative 5 right there. And so my function is looking like this right here. Okay? Let's take a look at this next one. We want to find the zeros of my polynomial function. Okay? We're going to find our zeros. Now, if you can see, we know there's going to be 5 zeros. Okay, now they could be, all 5 are going to be real, they're going to be some real and complex, and so on and so forth. And so what are we going to try as one of our values? Well, remember, use your theorem that we developed before. We have 8, we have 1, which means we could have all the factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and so on and so forth. So remember, what am I going to do? Let's try 1. We're going to do some synthetic division. 1, remember, x to the 4th power is 0, x to the 3rd power is 1. 2, negative 12, and 8. Let's do this real quick. We got 1, 1 times 1 is 1, 1 times 1 is 1. We got 2, 2 times 1 is 2, we got 4. 4 times 1 is 4. We get negative 8. We get negative 8 right there. That's 0. That was positive 1 was one of my zeros. So I'm going to write it over here. X is equal to 1. That's one of my zeros, one of my factors. Okay, is going to be this guy right there. Now, who knows what's going to be another factor here? I'm not really sure. So let me try. I'm going to try, let's try 1 again. Okay, so we got 1, 1, 2, 4, negative 8. So we're going to bring this guy down. Remember, I'm just kind of guessing here. I'm doing some synthetic to try to help myself out. We got 4, we got 8. 8 times 8. Oh, what do you know? We got another 0. We got x is equal to 1 again. That's another 0. And so now I'm left with some values here. Let me try 1 again. Who knows? It could be a multiplicity of 3. Well, I know it's not going to be positive 1 because you see how all these numbers are positive. And I'm going to need a negative to cancel out. So let me try negative 1. Okay? Is everyone cool with that? We have positive 1, 2, 4, 8. They're all positive. I need a negative to cancel something out. So we got 1. 1 times 1 is negative 1. We got 1. 1 times 1 is negative 1. We got 3. That's negative 3. No, that didn't work. That didn't work. So that negative 1 didn't work. Okay, so I'm going to kind of erase that if that's okay, because that didn't work. Let's try negative 2. Let's try negative 2. We got 1, 2, 4, 8. Let's bring this guy down. We got negative 2. We got 0. We got 0. We got 4. 4 times negative 2 is negative 8. Ding, 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 ding. X is equal to negative 2 is one of my zeros. Okay, I'm doing really good. I have 3 real zeros here. I have 3 real zeros. These guys are all real. Okay, these are all my real zeros. Now let's take this last function that we have here, and what do we have? We have x squared plus 0x plus 4. Now if you can see, once you get down to the x squared, you can try to take a look at factoring this guy. And remember, I set this equal to 0. X squared equals negative 4. X is equal to plus or minus the square root of negative 4, which means x is equal to plus or minus 2i. And so there's my last 2 zeros. We have x is equal to plus 2i, x is equal to negative 2i. And my last 2 zeros are going to be complex. So there are all my zeros there. We have 3 real zeros. 2 of them are complex. So you're going to try to do some synthetic division, and then once you get down to your x squared, your quadratic, you can try to do some factoring to find out the rest of them there. Okay, that was example 3, finding zeros of a polynomial function. Now remember, complex zeros always come in conjugate pairs. So just like in that last problem, remember we had 2i, positive 2i. Well, negative 2i always comes in a pair. They always come in pairs together, which means a plus bi, a minus bi will also be a zero of the function, and we call that a conjugate. Which means if here it says find the 4th degree polynomial with real coefficients where x is equal to negative 1, he's a 0, x is equal to negative 1, he's a 0, x is equal to positive 3i, he's a 0, which means you know x is equal to negative 3i is a 0 as well, because they come in what we call conjugate pairs. So what are my factors? We have x plus 1, that gives me negative 1 and negative 1. We have x plus 3i and x minus 3i, and those are all my factors of f of x. Okay, always start with the complex ones because they're the easiest to do your math with. Okay, so we have x plus 1, we have x plus 1, and we have x times x is x squared. You can see the middle number is going to cancel out because it's positive 3ix and negative 3ix. They cancel each other out. And we have negative 9i squared, which is the same. Now I can also do this, the foiling on this first guy. We have x squared plus 2x plus 1. And here we have x squared. Remember, I squared is equal to negative 1, which means he becomes plus 9 right there. And now I'm just going to do some foiling here, or some distributing. I'm going to distribute x squared to everything in here. So we have x to the 4th plus 2x to the 3rd plus x squared. Now I'm going to distribute my 9. We got 9x squared. We got 18x plus 9. I add all of that up, and I have x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. And that is my polynomial, this 4th degree polynomial of this function. Okay. Let me go through, I think, one more example here. This is going to be maybe one or maybe two more examples. We're going to factor our polynomial completely. Okay, and so here we have x to the 4th times minus x squared minus 20. Okay, so what is the factors of x to the 4th is x squared and x squared. What are the factors of negative 20? That would end up giving me negative 1 would be negative 5 and positive 4. And you can see this is just a factoring problem here, isn't it? So we have x squared minus 5, x plus 4. And that is what we have right there. Now, if you can see right here, this guy, if we set these equal to 0, if we set x squared minus 5 equal to 0, we have x is equal to 5. Sorry, x squared is equal to 5. X is equal to plus or minus root 5. We set this bad boy equal to 0. X squared plus 4 equals 0. We got x squared equals negative 4. X is equal to square root, sorry, plus or minus square root. Negative 4. X is equal to plus or minus 2i. And there are all my factors there. I have two real zeros at plus or minus root 5. I have two complex zeros of plus or minus 2i. And if I wrote this as a factor, we would have x minus root 5, x plus root 5. We would have x minus 2i, x plus 2i. And that would be factored completely right there. And one last example, this is example 6, finding the zeros of a polynomial function. We have this function, we know one of our zeros here. We know one of our zeros is 1 plus 3i, which means 1 minus 3i is my other zero because they come in complex conjugates. Now what do we know is, what's our factor is x minus 1 plus 3i, and x minus 1 minus 3i. Okay, and so what do we want to do here? We want to distribute this negative. So we have x minus 1 minus 3i. Okay, so we have x minus 1 minus 3i. We're going to distribute this negative, x minus 1 plus 3i. Okay, now we're going to do some foiling here. So we have x minus 1 times x minus 1, that's x minus 1 squared. The middle number is going to cancel out because it's a complex conjugate. Minus 3i times positive 3i, that's negative 9i squared. What do we know about I squared? I squared is negative 1, which means this is really x minus 1 squared plus 9. Okay? And what do we know about x minus 1 squared? The x minus 1 squared, if we do our foiling here, is going to be x squared minus 2x plus 1 plus 9, which means x squared minus 2x plus 10. This is that complex conjugate right there. Okay? Now, if we know that this is a factor, we can do our long division. Okay, x squared minus 2x plus 10. We're going to divide that into x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. We can't do synthetic because this is not just a simple factor of x minus 2 or something like that. So how many times does x squared go into x to the 4th is x squared. So I'm going to distribute x squared times all of this junk. So we have x to the 4th, x squared times negative 2x, that's negative 2x to the 3rd. X squared times 10 is 10x squared. What do we do with long division? We switch our signs. So he becomes 0. He becomes negative x cubed. He becomes negative 4x squared plus 2x. So how many times does x squared go into negative x cubed? That's negative x. I'm going to distribute this negative x to everyone. So we have negative x cubed. Negative x times negative 2x is positive 2x squared. Negative x times 10 is negative 10x. I'm going to switch my signs when I do my long division. So negative 4x squared, negative 2x squared, negative 6x squared, we get 12x. We bring this negative 60 down. How many times does x squared go into negative 6x squared? Is negative 6. And what do you know? Do you see what's going to happen? Negative 6x squared. We get 12x. We get negative 60. Switch my signs. Everything equals 0. So what are we left with? This was my first factor. My first factor was this guy right here. I'm going to underline. I'm going to box him in black right there. That's my first factor. That came from my complex guys. My next factor is x squared minus x minus 6, which we can factor out x and x. What are the factors of negative 6? Is negative 3, positive 2. That gives us that negative 1 in the middle. And here are my factors right there. So you can see how if I was going to rewrite this in factors, okay, and I'm going to erase all of this long division. I know you can rewind the video if you need to go back. So I'm going to erase all this guy right there. If I were to develop this guy to factor this function into factors, I would have x minus 3, x plus 2, x squared minus 2x plus 10. That is the simplest factors that I can make this out to be. And of course, this guy right here, the underline, he is complex, obviously. He's complex, and the factors of those complex are up at the top up here. Okay? That was 2.5, the Fundamental Theorem of Calculus. I know you had fun, and I know this video left you mental. See you guys.